In this video, we're going to review all the different types of factoring. So when we're factoring, the number one thing is that our first step is to always look for a GCF. So no matter what type of factoring we're doing, our first step is to always look for that GCF. Then after that, we can kind of group our type of factoring by the number of terms. So if something has two terms, we should check to see if it's a difference of squares. So meaning that's two squareds that are subtracted. So for example, if I have x squared minus 64, well, x squared is x times x, 64 is 8 times 8. So this will factor into x minus 8, x plus 8, or x plus 8, x minus 8, same thing. And that's how we factor a difference of squares. Now the next one is one of the ones where, again, we need to look for a GCF first. So if I look, I can see that my GCF of 18 and 2 is going to be 2. And both of them have at least one n. So my GCF is going to be 2n. When I take out a 2m, I'll have 9m squared minus n squared left in the parentheses. Now, what's in the parentheses is a difference of perfect squares. So the 9m squared will factor into 3m and 3m. The n squared will factor into n and n. So the final answer will be 2n still in front with 3m minus n and 3n plus n on the inside. Now, the next option would be something if we have three terms, we're going to have a trinomial. And we have two different types of trinomials. We have a trinomial where a is equal to 1 and a trinomial where a is not equal to 1. So when a trinomial is equal to 1, or the a is equal to 1, excuse me, we're going to factor by thinking about factors of c that add to b. So I need to find two numbers that multiply to negative 42 but add to negative 1. So that would be negative 7 and positive 6. Now again, we always want to check for a GCF first. So in this next example, I'm first going to take out a GCF of 2. Then I'm going to think about what multiplies to 25 but adds to 10 would be 5 and 5. Which I could rewrite as 2 times w plus 5 squared. Notice how when I took out that GCF, I wrote it in front, and I continued carrying it in front all the way down. Now, for when I have a trinomial where a doesn't equal 1, again, I still want to look back to my first step. So I still want to look for a GCF for this first example. So if I think about 30, 27, and 6, well, 6 goes into 30, but it doesn't go into 27. So the next biggest number that divides all of these is 3. So I'm going to take out a GCF of 3, and I'm going to get 10x squared minus 9x plus 2. Now my a value is now 10, and that is still not 1. So my first step is I'm going to do my new a times c, and I need to think about what multiplies to that number but adds to the b number. So I'm going to do 10 times 2, which is 20. So I need to find two numbers that multiply to 20 but add to negative 9. So the two numbers that are going to multiply to 20 but add to negative 9 are going to be negative 5 and negative 4. So now I'm going to split this middle. So instead of a negative 9x, I'm going to have a negative 5x minus 4x. I'm going to bring down this first term, and I'm going to bring down this last term. Now don't forget about this 3. I'm going to bring him in later just because I don't want to confuse him with my factoring. Once I have 4 terms, I'm going to factor by grouping. So that means I'm going to take the GCF from each group. So my GCF from this first pair is going to be a 5x. And when I divide that out, I'll be left with 2x minus 1. The GCF of my second pair is going to be a negative 2. It's negative because this first number is negative. Once I factor out the GCF from each, I know I did it correctly if what's in my parentheses is the same, which in this case it is. It's both 2x minus 1. So it means my final answer is going to be the one that's the same. So that 2x minus 1 times, now we're going to take those front numbers, the 5x minus 2. Those are going to get their own parentheses. So 5x minus 2. And like I said, let's not forget about this GCF over here that we talked about, the 3. He's going to go in front. So this is what my final answer would look like. The last one is if we have 4 terms. Now if we have 4 terms, we're going to do something factoring by grouping, which we actually just did with trinomials. So when we're grouping, I'm going to put my 4 terms into 2 groups, or 2 pairs. Then I'm going to take the GCF from each pair. So if I look at this first pair, my GCF is going to be a squared. So I'm going to take an a squared from each, and I'll be left with 2a minus b. Now if I look at the GCF of my second pair, I can see that my GCF is 5. So again, I'll be left with 2a minus b. I know I did it correctly because what's in my parentheses is the same. So my final answer is going to be 2a minus b. I rate the one that's the same 1 time. Then I'm going to take the ones that are in front, a squared and 5, and that's going to become its own parentheses. So I'm going to have a squared plus 5 because my 5 is positive. And this will be my final answer.